Here's an example involving some sum identities. Given that the cosine of alpha is equal to 8 over 17, and that the tangent of alpha is less than 0, and given that the cotangent of beta is negative 20 over 21, and the cosecant of beta is greater than 0, we're going to find the sine of the sum, cosine of the sum, and tangent of the sum of alpha and beta. Now, hopefully, these kinds of problems are starting to look familiar by this point in trigonometry. So first thing I want to do is actually draw both angles. I'm going to start by drawing alpha. Now if you're going to draw an angle, first question you should pose is, in what quadrant will I be drawing this angle? Now given that the cosine is positive, I want to remove the two quadrants where cosine is not positive, and given that tangent is negative, I want to remove the quadrant where the tangent is positive. That lets me know alpha is going to be a quadrant 4 angle. Where in quadrant 4 you draw it doesn't really matter as long as it's in there. So this is our angle alpha. Now according to SOHCAHTOA, cosine is supposed to be the adjacent over the hypotenuse. That'll be an adjacent side of 8, which is positive in quadrant 4, and a hypotenuse of 17. As soon as you have two sides of your right triangle, we will proceed to the Pythagorean theorem. A squared plus b squared is r squared, also known as 8 squared plus b squared is equal to 17 squared. Simplifying these numbers, we get 64 plus b squared is equal to 289. Please feel free to use a calculator to help you out. Subtract 64 from both sides, we get that b squared is equal to 225, letting us know that b is equal to plus or minus the square root of 225, which happens to simplify completely, as 225 is a perfect square. That will be negative 15. Why is it negative? Well, we're in quadrant 4, so the x-coordinate should be positive and the y-coordinate should be negative. That lets us know that our opposite side is going to be negative here. That also allows us to figure out the value of the sine of alpha as well as the cosine of alpha. Now, cosine of alpha we technically already had, that was 8/17. The sine of alpha, though, we can now fill in that value. That's negative 15 over 17. We're now going to repeat this procedure with beta. All students take cash. All right, so we have been told that the cotangent of beta is negative, so we want to get rid of the places where the tangent would be positive. We were also told that the cosecant of beta is positive. The reciprocal of the cosecant would be the sine, so I want to remove the quadrants where the sine is not positive. That lets us know beta is going to be in quadrant number 2. Now, the two sides that we were told would be the cotangent, that's the adjacent side, over the opposite side. So adjacent side of 20, opposite side of 21. Given that we're in quadrant 2, though, we will want our x-coordinate to be negative. So negative 20 and 21. You know two sides of a right triangle. Next thing to do would be to find the third side. So a squared plus b squared is r squared. That'll be negative 20 squared plus 21 squared is equal to r squared. Simplifying the left-hand side, this is 400 plus 441 is equal to r squared, letting us know that r squared is equal to 841. Now r should never be negative, so r is going to be the square root of 841, which simplifies completely to become 29. With that in mind, we can now draw a conclusion about the sine of beta and the cosine of beta. So sine of beta is the opposite over the hypotenuse. That'll be 21 over 29. And the cosine will be the adjacent over the hypotenuse, or negative 20 over 29. I'm try to fit all this on the same piece of paper, but do keep in mind that the original goal was find the sine, cosine, and tangent of the sum of alpha and beta. So for sine of alpha plus beta, our formula is, we start by simply covering up the second angle. That'll be sine of alpha. Second thing you copy down is always cosine of beta. Sine is same, so for plus, we'll see a plus. And then use the other two other two ratios. So cosine of alpha and sine of beta. Sine of alpha, we had from up here, that's negative 15 over 17, times cosine of beta, which is right here, that'll be negative 20 over 29, plus cosine alpha is right here, 8 over 17, and the sine of beta is 21 over 29. Now, I've seen considerably worse excuses to turn to a calculator when I see something like 17 times 29, 17 times 30, that's 5, 10, 4, 93. Now I'm going to doubt myself, though. Oh, boy. 29 is... oh, nailed it. All right, cool. All right, good stuff. Feeling good. Plus 8 times 21, that would be 8 times 2 is 16, and 8 times 1 is 8 over 493. Then combining our two numerators together, I like that we always get this common denominator here. That's really nice. So it'll be 468 over 493. Cool. All right, next up. The cosine of alpha plus beta. So the way that this goes is first cover up that second angle. That'll be cosine alpha. Second thing I write down is always cosine beta. Cosine is contrary, so that'll be a minus. And then pop in the other two. So sine of alpha, sine of beta. This will be equal to cosine of alpha. Cosine of alpha we had right back up here. That's 8/17. Please note the extra use of parentheses around all of these things. Cosine of beta we can borrow from the last one since that's always in the second position. Minus sine of alpha. Sine of alpha was our negative 15 over 17. Negative 15 over 17. Times the sine of beta. Sine of beta is 21 over 29. All right, let's see if we can clean this up. Positive times negative will be negative 160 over that common denominator of 493. I see a minus a negative, that'll become plus. 15 times 21, that'll be 315 over 493. Combining these two numerators together, that'll be 31 minus 16, that'll be 15. So 155 over 493. Now for the tangent of alpha plus beta, it looks like I begrudgingly have to start a second sheet, but that's okay. I will be borrowing some stuff from the first sheet though. So one possibility is we could do that the tangent of alpha plus beta is the tangent of alpha plus tangent of beta over 1 minus the tangent of alpha times the tangent of beta. Or we could use an identity for this, and this is what I'm going to recommend that you do. There is a quotient identity for the tangent, and that quotient identity says that that would be the sine of alpha plus beta over the cosine of alpha plus beta. The reason that I would encourage this is because in this form, this will be a fraction plus a fraction over 1 minus a fraction times a fraction. That's just too much. This, we already found the sine and cosine anyway, so we might as well use them. So from the first sheet, the sine is 468 over 493. The cosine is 155 over 493. The over 493s can cancel out by saying, since it's a fraction divided by a fraction, we can multiply by the reciprocal. That way the 493s will cancel out, and we'll be left with 468 over 155. Now, in the event that I asked you to identify the quadrant of alpha plus beta, the thing that I would need to point out is that the sine was positive, the cosine was positive, and the tangent is positive, letting us know that alpha plus beta is going to be a quadrant 1 angle. And if I were to draw in the associated right triangle, the sine was 468 over 493. The cosine was 155 over 493. And now the tangent we see is 468 over 155. So that works out just peachy.